So, hello everyone. Today I will talk about jointly recognizing hand gesture and estimating matrix depth for 3D interaction based on just RGB input. Our topic is about user input for 3D interaction and AR/VR. Actually, what we want here is mainly the 3D hand position. This has been done traditionally by external tracking, which can give you the XYZ position of the hand. Our solution provides this XYZ hand position based on just RGB input. Here you can see from the video, on the left hand side is the raw RGB input, and on the right hand side is the XYZ estimation from our system. Our estimation is robust on the gesture variation. You can see the smooth transition from palm to pinch. And here is an app to demonstrate our input functionality. We bring up some content cards by pinch gesture, then we can go through the card by detecting palm and also its depth. And we trigger a call by face gesture. You might be wondering why we not use depth camera. And you saw from John's previous talk, the fidelity from a depth camera is obviously very high, but there are still several issues for us to use depth camera on head-on devices. For example, the active illumination-based camera has issues with power consumption and heat emission, especially when we wear those devices on our head. And passive still require physical baseline, and this will impact the overall size of our devices. Finally, even if there will be very small depth camera in the future, right now there are already around 6 billion devices with RGB camera sold out. Tapping into this large install base is a main motivation for us to explore the possibility to use just RGB camera for 3D interaction. Here's the overview of our technical pipeline. It's a per pixel labeling process based on multi-layer random forest. The first part is for gesture recognition. It starts from RGB input. After segmenting the hand out, the binary mask will be put into a series of random forests to recognize gestures and also to remove the background noise after segmentation. This is mainly based on our previous work. If you are interested in the details, you can refer to our last year's quiz paper. Our main contribution of this technote is to extend the gesture recognizer to a hybrid process which can jointly recognize hand gesture and also estimate the hand depth together. We achieve this by a combination of classification and regression forest. You might be asking why we not just directly counting the pixels for the foreground and then estimate the depth by interpolating this count. Actually, there are several reasons why this kind of method doesn't work. For example, those images, they are same gestures and then the same depth, but just a slight change, appearance change will drastically change the depth estimation if we just count in the foreground pixels, even though those images are perfectly segmented. So we decided to use a learning-based regression tree to cover more variation in terms appearance, hand appearance, and also background noise. For a regression tree, a foreground pixel will traverse down the tree by simple evaluation at each level. Once it reaches one of the leaf nodes, a pre-node continuous distribution will be assigned to that pixel. In our case, this continuous variable is the matrix depth. And the depth estimation of the whole hand is determined by averaging all the estimations for all the pixels together. So putting all the pieces together, this is how our forest architecture works. First, coarse depth forest will classify the hand into several discrete hand depth intervals. And then a hand-shaped forest corresponding to the pre-estimate coarse depth will be executed to recognize hand gesture and at the same time to remove most of the background noise. Finally, a depth regression forest associated to the pre-classified hand gesture will be run to estimate the final hand depth. By splitting the whole task into several multiple easier subtasks, we can use multiple channel forests rather than a single very deep forest to reach good performance. This is important to run our algorithm for like memory constrained devices. So let's move the result. Here is the qualitative comparison of our estimation to the ground truth. On the left-hand side is the average ground truth from depth camera, and on the right-hand side is our estimation. Both images are showed in false color coding. And we can see here our estimation is quite accurate with the ground truth. And here is the quantitative comparison. The red line is the ground truth, and green line is our method. The blue line is just by live counting. You can see our method tracks the ground truth quite closely on the gesture variation. Our average error is around 2 centimeters, while the live counting is about 9 centimeters. So there are a few applications to demonstrate our input functionality. The first one is the air app. We can scroll the virtual furniture list by palm gesture and also its corresponding depth. By switching to the pinch gesture, we can change the size of the furniture. And the second application is about 3D menu system. We can use palm gesture and also its corresponding 3D point to scroll the menu list, then use face to select item. Clearly, there are several limitations of our algorithm. First, we can only detect discrete gesture and regress the depth for those gestures. And second, our depth estimation just one single value for the whole hand. And for most of the VM-based application, if there is no light, it will pose big problem. So to conclude, we present a machine learning-based approach to jointly recognize hand gesture and estimate its corresponding depth. We show quantitative evaluation, and also we demonstrate our input functionality with some applications. So our object is not to replace in the depth camera, but just to show the possibility to use RGB camera for 3D interaction. So thank you.
So it seems like the classification is based on the single pixel.
Yes, pixel.
I'm just wondering if you can, how would you take into account the neighbor relationship between pixels for better classification?
Oh, so actually I ignore the details. It's similar with body tracker method, also for it's the similar method. So during the training, we also check the neighboring relationship. I just ignore the technical details. So if you're interested in the detail, you can refer to the waste paper.